Welcome to another episode of Directed Energy's Technical Quick Tips. My name's Martin Jones and I'm with the Applications Engineering Department. Today we're going to be talking about how to determine your maximum load capacitance for our PVX-4100 series high voltage pulsers. Now our high voltage pulsers, we have 4 of those and they are 100 watts of maximum output power that each one can do, except for one of them, which is our PVX-4100, which will be able to deliver 150 watts of output power. Now in determining what your maximum load capacitance will be for these units, you must take 2 things into consideration: the capacitance of the unit itself, which is approximately 200 puff, and our cable. Now this coaxial cable that connects our capacitive load to the unit is a capacitor in itself. And for example, this cable here is RG, is an RG59, and it's approximately 21 puff per foot of capacitance. And a 6-foot cable is 126 puff of capacitance. So we are going to do an example of determining what the max load capacitance is for your PVX high voltage pulsar. And in this example I'm going to be using a PVX-4100 using this RG59 coax cable. Now in order to do this, power to determine this is your capacitance times your voltage squared times frequency. So we want to know what our capacitance is because we already know what our power is, which is 100 watts. So now we want to figure out what C is, equals 100 divided by your voltage squared. Now the voltage is total voltage, whether you're going positive or negative on this, is total voltage swing. So on a PVX-4100, say you're going positive 1.75 kilovolts and a negative 1.75 kilovolts. That's a total of 3,500 volts that you will need to use for your voltage. Times frequency. Now you can pick any frequency you want. For this example, I'm picking 5,000 hertz or 5 kilohertz. Now this C equals a total of 1.632 nanofarads. Now that's the total capacitance for this unit. But now we have to, in order to figure out what the load capacitance is going to be, we need to subtract 0.200 nanofarads or 200 picofarads for your unit capacitance. Then subtract 0.126 nanofarads or 126 picofarads, and that is from the 6 feet of cable that is supplied with the unit. And we get a total of 1.306 nanofarads or 1,300 picofarads approximately. Now this can vary as much as plus or minus 10% because each unit is not exactly 200 picofarads for its internal capacitance. So this can actually vary a little bit. But this gives you a good starting point, and that would be the maximum load capacitance for the PVX-4100. Now you can apply this to each one of our other units, our PVX-4110, our 10 kilovolt unit, which is 100 watts, our PVX-4130, which is a 6 kilovolt unit, which is 100 watts, and our PVX-4150, as I said before, is 150 watts. And you can use this formula and manipulate this formula any way you want to figure out, if you know your capacitance and know your frequency and you want to know what your voltage is, you can do the same thing. Thank you very much, and I hope you join us again.